Hey everyone, second part of this lesson in terms of taking derivatives. So we're kind of going past the idea that we're going to use first principles. These questions will get really crazy with first principles. We're just going to use the rules. And the rules are on your formula sheet, or they're written here on the top of the page. If you ever have a sine function, the slope of a sine function is the cosine function. So that's the first layer. If you have a cosine function, its slope is negative sine of that function. So again, that's kind of the first layer. This second part here is just about the chain rule. So if your function is ever more complicated than just x, you have to consider what the derivative of that more complicated function is. Same thing here. If you have ever more than just sine of x as part of your answer, you have to consider what the more complicated part is. So our examples kind of show that. Sine of 2x. So the sine part becomes cosine. Sine 2x is cos 2x. So that's the first layer. All right, so the sine function becomes the cosine function. And the second part is what's the derivative of 2x? So the derivative of 2x is 2. So you're going to always have probably a couple of layers to your questions. And again, the function can be more complicated, x squared minus 1. So the derivative of sine is cosine. Cos is x squared minus 1 because the sine was x squared minus 1. So that first layer is always just kind of repeat. The second layer is what's the derivative of the function. Example C is just a product rule. Again, you got x times sine x. So you use your product rule. What's f, what's g, what's f prime, what's g prime. Plug and simplify. And if you have product rules, you can have quotient rules. All right, so again, quotient rule, top function, bottom function, and apply the rules and then simplify. Cos of a function squared is the same thing as the whole function being squared. So it's like the power rule. 2 comes down, is 2 cos x. What's the derivative of cosine? Derivative of cosine is negative sine. Now, what happens in some of our questions, again, because we end up with a new identity or something that you learned back in Math 30, 2 cos x sine x is actually the double angle for the sine ratio. So when you have double angles that simplify, we expect you to write it as a single ratio. And then if you've got an abstract derivative of ax plus b, again, that's kind of that second layer. B is a constant, it would just go away. Derivative of ax is a. So our rules are very basic. Wherever you have a sine function derivative, repeat the cosine with that angle, and then take the derivative of the more complicated value. If you've got cosine, take negative sine of the function, and then take the derivative of that theta. And if we go and do a couple more examples, cos of sine x, so first layer is cos, cosine becomes sine. Actually, cosine becomes negative sine, a little negative hiding in there, and the sine x just stayed. What's the derivative of sine x is your second layer. Sine x and sine y. So when you have the y in here, it becomes implicit differentiation. Sine x is simply cos x. Sine y should be just cosine of y. But because this is not a function of x, you do the derivative of it, dy dx. And then you just rearrange and you solve. So you minus cos x from both sides and divide both sides by cos y. So some of the skills that we had in past chapters come through and get applied to trig. So that's why trig is kind of neat. Now, how do you add layers to a question? Well, you add layers to a question by simply making it a rational expression and making you use the quotient rule, understanding that you've got points that have the cause dividing by 0. So there's lots and lots of math in a question like number 2. Start off with, though, we just did the quotient rule. You've got a numerator, you've got a denominator, and you basically plug in and then you simplify. And here's your expression. That's your slope. What's happening at pi over 6? What's the equation of the tangent line at x equals pi over 6? So you put pi over 6 in for all your x's. If it says cos 2x, 2x then is 2 pi over 6, which is pi over 3. So we can find the slope again anywhere on the curve if we know the x value. And then plug it in and simplify. And again, I get a whole bunch of complicated fractions. So I've got the 4's in the bottom. I multiply by 4, and then just simplifies to my slope is 3 root 3. So the first half of this question is just about a derivative and finding the slope. The second part of the question is, what's the equation of the tangent line? So find the equation of a line. You need to know the x and the y value. So your y value goes right back to the original function. So what's the sine of 30 degrees divided by the cos of 60 degrees, or sine of pi over 6 cos of pi over 3. So that y value becomes 1. So now you've got a slope of 3 root 3. You got a point of pi over 6 and 1. You could just plug it in the formula and simplify. And it looks like I was just not ambitious enough to kind of keep that going. But that's what would be your last step. Okay, so you've got some questions to practice then, right? Have some fun with them, right? There's a little bit of Shrek in here in regards to the idea that the layers can just kind of keep on being added in. So have some fun, and we'll talk to you next week. Take care.